A number of you had questions about workbook assignment 37.5, the second section where you had to say how some sets were related. They were symmetrical sets. So I just wanted to go through that with you. On the screen right now is the Webern excerpt. I've already put in the normal order that most of you got, and then the prime form for the sets is 0, 1, 6, 7. So all the sets are related. We know they're related because they have the same prime form. So first I want to talk about what a symmetrical set is. On this screen I have the clock face marked with sets A and C, which are the F sharp, 6, the B, the 11, F is 5, and C is 0. So you see those highlighted in teal. This set is symmetrical because it has symmetrical spacing. There's spacing of 1/2 step between 11 and 0, between the B and the C. There's a spacing of 5 between the C and the F, spacing of 1 between F and F sharp, and then a spacing of 5 between the 6 and the 11. So in spacing, this is symmetrical because there's 1/2 step followed by 5, then another 1/2 step followed by 5. The same thing is true of our segment B. You see the same spacing. We have our 1/2 steps between the B and B flat, the 1/2 step between E and F, and then 5 1/2 steps as that larger gap. So because of the symmetry in these sets, the larger gap has the same spacing. In both of these sets, the spacing is 5 for those larger gaps. That means that our normal order actually can have two different possibilities. So if we're looking at right now on this screen set B, the normal order is 10, 11, 4, 5. I'm starting on 10 because that is the note that is after that large gap of 5. But I could just as easily start after the other gap of 5 and begin my normal order on 4. So 4, 5, 10, 11 would also be a possible normal order. Because of this, I have a number of different possibilities of ways that these sets are related by transposition and inversion. So I'm going to take you through that series of steps right now. So segment A and B, I'm just going to write out my normal order, and we're going to do some comparisons. Let's compare and see what we find for transposition. So the question always is, how do I get from my first set to my second set? Well, if I'm looking for transposition, I need to add something to get from my first set to my second set. So how do I get from 11 to 10? I can add 11. Remember that there is another way to order segment B. There's also another way to order segment A, but you can't change both of them because that will end up with the same spacing. If we look at that over here, the other order for A is 5, 6, 11, 0, and the other ordering for B is 4, 5, 10, 11. If we try to figure out this transposition for those, well, how do I get from 5 to 4? I add 11. So that relationship, I haven't found anything different there. So I'm going to try the other order for B, which is 4, 5, 10, 11, and I'm going to compare that to my E 0, 5, 6 for set A. So then the question is, how do I get from 11 to 4? What do I need to add to 11 to get to 4? The answer is 5. So this question 3, if I'm comparing A and B by transposition, my first blank, T11, I have to apply transposition at the level of 11 half steps to set A to get to B. And then I can also transpose by 5 to get to B. And comparing B and C now, we'll do the same thing. B is TE45, C is E056. So now we're going the other way. How do I get from 10 to 11? Looking at transposition, well, I add 1. So T1 would go in that first spot. And then I need to try the other order for C, 5, 6, E0. How do I get from 10 to 5? Well, I can add 7 to that. Let's work with inversion now. Again, I have set A, set B. The normal order for set A is E056, and a normal order for B is TE45. For inversion, I'm going to look at the cross relationships here. So I'm comparing the first note of the normal order of set A to the last of set B, and I'm adding those together. If all of these little crosses add up to the same thing, I know that these sets are related by inversion. So if I look at E plus 5, so E plus 5, E plus 5 equals 16, which is 4. T plus 6 equals 16. 5 plus E also equals 16, which is 4. And 4 plus 0 equals 4. So these two sets are related by transposition level of 4. And I can put that into my workbook page. And remember, I have another possible ordering for set B. So 4, 5, TE, I'm going to do the same thing. Compare those crosses. They should add up to the same number. And they do. Can you figure out what number that is? Pause the video and try it yourself. And then come back. And if I'm adding up these cross numbers, 6 plus 4 is 10. 11 plus 11 is 22, which is also 10. 5 plus 5 is 10, and 0 plus t is 10. So these two are related by T10I. And I could put that in my workbook page as well. You could write that as 1, 0, as that actual 10 as well. And then finally, I'm going to compare B and C again. Now for inversion. Let me move that over a little bit. So set B, normal order TE45. Set C, E056. I'm looking for inversion, so I'm going to compare those crosses. T plus 6 is 16. E plus 5 is 16. I have another E plus 5, and 16 breaks down to 4, which is 4 plus 0. So these are related by T4I. The video, sorry. Let's try this again. TE45 is B. We'll start over. C, the other order is 5, 6, E0. There we go. So now pause the video and find the transposition level. Come back. I'm adding the crosses. T plus 0 is 10. 5 plus 5 is 10. 11 plus 11 is 22, which breaks down to 10. And 4 plus 6 is 10. So again, we find that T10I relationship. I hope this video helped explain a little bit why there are two possibilities for everything here when we're comparing things. And it's all because the set is symmetrically organized with that half step, then 5 half steps of spacing, 1 half step, then 5 half steps of spacing. And we saw that in the organization around the clock face. If you still have questions about this, let me know, contact me, and I'll meet with you and we can talk through it.